When we're talking about projectile motion, whether it's a projectile that is launched from a horizontal surface, like it's launched off the side of a cliff, or it's a projectile that's launched at an angle, okay? We know two things. We know that the x is what kind of motion? URM. The x is URM. And what about the y? UAR. The y is UARM. All right? So we're going to look at these four stock equations, and we're going to see what happens to these four equations when we're looking at either the URM or the UARM version of it. In URM, we know that velocity is what? Constant. Therefore, it does not change. So, if we look at this equation, let's look at equation number 1. Are there any things there, first and foremost, that can cancel out?
VF, VI.
One of the first things you should be looking at when you look at these equations is what chunks of variables can you just get rid of? Because that makes your life a lot easier when there are less letters in an equation. So if you look at equation number 1 and you're only looking at URM, that whole back chunk, acceleration times time, you get rid of it because you don't have any acceleration. So by doing that, we end up with what as an equation here?
VF equals V initial.
VF is going to be equal to V initial. Why?
Because since velocity is constant, it's never changing. Your initial is never going to change.
Your initial is never going to change, so they're going to be the same. VF will equal VI in this situation. Now, what about, and I want you to think about this, what happens in the Y? How would this equation be written in the Y? Here's where it's going to become super important to include your X and your Y subscripts when you're carrying out these equations, because your V in the Y is going to be different than your V in the X. Okay? So you're going to have to make light of that. We have to remember here that horizontal motion is URM, whereas vertical motion is UARM. That acceleration is going to give us those concrete UARM equations that we know, the four equations. If we look at equation number 2, x final is equal to x initial plus 1/2 bracket v initial plus v final bracket times time. How does that actually change? Here's the deal. If we want to add those two numbers, because we know that in the x, v initial will equal v final, because it's uniform, it does not change. It's basically a wasted erase. Okay, if we had a numerical value of, let's say, 3 for our initial velocity, that would imply that our final velocity is also 3. And if we're going to add 3 plus 3 and we're going to divide it by 2, we're going to be stuck with the same amount. So why do that extra step? Okay, so we end up being left with our x final being equal to our x initial plus what you said?
Plus v initial.
Delta t? All right, now let's look at this in a UARM context. How does this equation differ? Because we're dealing in the vertical, you're saying that x's disappear. We're now dealing with y's. So we have y final is equal to what? It's going to be equal to y initial plus 1/2 VIY initial plus VFY, okay, times delta T, correct? Now, the reason the Y's and the V's stay there is because we know that our Y velocity changes. We know that it changes because there is acceleration in the Y. It's that simple. If we look at equation number 3 in the horizontal, right away we take out anything that is multiplied by that last acceleration because in URM there is none. So this goes away and we end up with exactly the same thing that we got for equation 2. We end up with x final being equal to x initial plus initial velocity, or the only velocity, times the time. How does this change for UARM? So when we look at equation number 3 in the Y, everything remains, and it remains. Now here's the interesting part though. You've got to, and I've got to add that in there, only include, there's an I in there, you've got to only include the initial velocity here. Now the initial velocity is not always going to be the same as the final velocity. What happens if it's starting from rest?
Then the T cancels out.
If it's starting from rest, then there is no initial velocity. Okay? Now, what about equation number 4? What cancels out?
Everything except the VX and VI.
Yeah, this whole back bit cancels out. So, what do you see?
The same as the first.
It's the same as the first one. So, in this case, we get VF squared is going to be equal to VI squared. So you can square root them and look at this. Do you see that this and this are the same and this are the same? What? Let's finish this and let's talk about the Y in this equation. What ends up happening? It's exactly the same,
Delta Y.
except it's in the Y. So we end up with oops, I want that to be green. We end up with VY final squared being equal to VY initial squared plus 2 times the AY delta Y. Okay? This is your equations. Now, if you're being asked to find the actual range or the horizontal displacement, you don't really have a lot of equations at your disposal. Okay? You are going to need to know these equations because I will not give you these breakdowns on your test. Right? You are going to need to know how to manipulate these equations when it comes to doing a projectile motion question.